Hi lads, in this video I'm going to go through the tetrahedron question on the bottom of page 17 from today's class. So starting off to draw our tetrahedron. Tetrahedron is basically a 3D shape made up of equilateral triangles all joined together. So to start off, we're going to go 30 degrees each way, as that will give us our 60-degree angles for our outsides. And we're told that the length of one of our sides is going to be 75, so therefore all sides are going to be 75 mm in length. So I take my 75 mm, swing it there, swing it there. What you see then is those 2 points will line up, giving me my base of my tetrahedron. To find the centre point, we're basically bisecting this angle here. So if I was to take a level line just there, that would be 30 degrees, leaving 60 left over. We use our 60-degree set square. We'll bisect that angle there and there. We'll do the same on the opposite side, and you'll see that they'll cross at that point there. And that'll give us the top point in our plan view, which is going to be the top of our tetrahedron in elevation. Next thing to draw is our XY line. We extend our points up then. To find the height of our tetrahedron, when we look along this edge here, we know that any line that's parallel with the XY line in plan is going to be a true length in elevation. So therefore we can take our 75 mm and swing it from here, because that's going to be a true length, because that line is parallel to the XY line. And that gives us the height then. We can connect that line there. I can draw this line here, giving us the elevation of our tetrahedron. Next thing we have is our cut taking place, and we're told that point 1 and 2 are 25 and 16 mm away. So I take my 16 to there, and I take my 25 to there, and the 25 is going to be the lower point down here, and the 16 is going to be the upper point here. So that gives us point 2 here, point 1 there. They can be joined together, so this is where our cut is taking place. And then point 3 we're actually given in our elevation. We're told that a total of 54 mm up. So we can take that up there, measure up our 54, take that across, gives us this point here, and that can be taken down to give us point 3 here. So point 3 there, there, and then we have 2 there and 1 there, and we can connect all those together now. And we can draw the rest for shape and heavy. And there's our elevation and plan set up now. I just draw my X line heavy as well. So we have our cut surface here and here. And what we want to do is try to figure out the true shape of that cut surface. So if we just use a set square for example, if I look straight down that there, I would see it as a true shape. If I was to tilt it along here, we'd see it as an edge view. So we can take an edge view here, looking along for example line 2, 1, to create an edge view looking out this way here. And then if we look in perpendicular to that edge view, i.e. looking in this way, we could then see a true shape. So that's what we're going to do to solve this question. We're going to take an edge view first of surface 1, 2, 3, and then we're going to take a perpendicular view of that to see the true shape. So the first thing we need to do is look along the line 2, 1 there. So we extend 2, 1 out, and then we go in perpendicular to that to our new x1, y1 line. So just using sliding set squares. I'll just draw my x1, y1 here. And we take out all of our points. Next thing we need to do is remember to always go 2 views back. So when we're taking, for example, our 3 points or 3 corners in our base, we go 1 view back, 2 views back. We have a look up, we measure from our XY line going up. That point there is on the ground, this point here is on the ground, and this point here is on the ground. So we're going to have that corner there, that corner there, and that corner there are all going to be on the ground. Our point at the top, we follow it up, it's going to be this height here. We take that distance on our compass, follow it down, follow it out. That gives the point out here. What we do is we can connect those together. So it connects to there, connects to there, and it connects to there. Next thing we have are points 1 and 2. So 1 and 2 are on this line here. The heights, they're on the ground. So 1 and 2 are going to be there. Point 3 then. Point 3 is up this height here. So I take the height of point 3, follow it down, follow it up there, and it gives me that height there, which is the exact same as this line hitting the edge there. That gives us point 3. What we now have is an edge view of our surface 1, 2, 3 there. It's an edge view of it. So remember, when we get an edge view, let's hold it like that there, and we look in perpendicular to it, we then see a true shape as a result. So let's draw the rest of this in heavy there then. The key thing there is we've got our edge view. And this surface here, or sorry, this edge here, we can't see it, it's hidden detail. So when looking that way, we can't see it there. And obviously the rest of it's been cut away then as well, so we need to include that. So now that we have our edge view, we can then look perpendicular to that to see our true shape. So your edge view, 1, 2, 3. And we start taking our shape out here. Making sure to take out all of our points. once again, our XY line is going to go perpendicular to that. So this one here, we have our X1 and Y1. This one here, we have our X2, Y2. Same idea again. When we take our distances, we're going to go 2 views back. So we'll take 1, 2, 3 first. So we go 1 view back, 2 views back. So we go from our X1, Y1 back into our plan. We get the distance of 1 there. We follow it up. We get 1 here. That's point 1. Take our distance back to 2. Follow it up along 2 there. Sorry, back there 2. Follow it up. We get 2 here. And then 3. 3 is along that line there. Distance from our X1, Y1 back to 3. Follow 3 out. Gives us that point there. And when we join those together, that'll give us the true shape of that cut surface. So that basically is our true shape. Then take the points all around it then. So for example, of our base points, we have 1 here. Take the distance in our compass. That's 1 corner of our base. Follow it up. Gives us that point there. Next corner is this one here. So that's going to be a really short distance there. Follow that up. Gives us that point there. And our last corner on our base is that point there. So we stretch our X1, Y1 out to there. And follow that one up. So those 3 can be connected now, giving us our base. And you can see that our base is passing through corners 1 and 2, because they're on the ground as well. Last thing we need to do is take our point at the top. So it gives our top point in somewhere out here. So there's our top point. Follow it up and out. Gives us that there. And they also connect to the corners of our base. So it connects there, there, excuse me, and this will pass through point 3 on the top as well, giving us there. And what we can actually see then, so we can see our sides there in our base, and there. That can't be seen anymore because it's been cut off, so we rub that part out. This will connect up to here, that will connect to there, and that will connect to there. And then we can't see our back line there, it's going to be hidden detail because it's being blocked by everything else in front. And the final line we can't see is our back corner running along here. And that's the question complete then. So drawing the true shape of the cut surface. So basically this is the surface here. We can't see the true shape in our elevation or our plan. So the first thing we did was we took an edge view to give us that line there, and we took it perpendicular to that edge view to give us our true shape up here. And remembering that we always go 2 views back for all of our measurements. Excuse me, when we're taking an auxiliary view.